divide by the natural log of 9. You get n plus 10 equals the ln of 78 over the ln of 9. So n will be equal to the ln of 78 divide ln of 9, subtract 10 from the whole 1. That's a 78, even though it doesn't look like one. 78, sorry. That's not a 4. Now, if I subtract 10 here, am I going to have to worry about the parentheses? No, because the order of operations clearly states to do division and multiplication first, followed by the subtraction. So this will work. And if you check with the back of the worksheet or whatever, it should be minus 8.0172. What do they have? Now, why did I put a 2 here? Because that's a 7. You round off. Are you guys getting on this?
Can you put 14?
Certainly. I have one more worksheet to go for. I want to get that to you. 14. What's going on with 14?
So you can actually go.
Okay, very similar to the last problem. We're going to first isolate the thing that has an exponent. So we'll have 20 to the negative 6n is equal to, what is that, 49 when I subtract 6 from both sides? Take the natural log of both sides. So you get this. I kind of did 2 steps there. I hope you guys are all right with that. I took the natural log and threw the exponent out front all at the same time. I'm going to divide through by negative 6 times the ln of 20 on both sides. So that these all cancel away, and n is equal to, well, that value right there. That's not something I could do with my head, nor could you probably. Ln of 49 divided by quantity negative 6 times the ln of what?
Crazy number.
It's supposed to be a negative 0.2165.
Oh, I messed up. You see, I didn't put the parentheses right there. Yeah, I had left off a pretty important parentheses. You see here where I was taking the ln of 49, I needed to put a parentheses and divide. I actually took the ln of 49 divided by a horrible number. You see the difference? It did not like that at all. So it actually gave me a funky answer. I believe that is imaginary. But we'll get to that later. This is the answer, right? When you do it correctly with the calculator, you get the right answer. It's easier than this button. I mean, everybody does it. And when the answer wasn't the way it should have, I went back and corrected the mistake, exactly what you guys would do. And furthermore, if I was really that concerned about it and didn't have a worksheet that already had the answer on it, I would then go plug it back into the problem and make sure that it worked, right? And if it didn't work, well then I'd go look at my work yet again. But since it matches up to the worksheet, I think I'll go ahead and say yes. All right. I have another worksheet to get to you, so you can have it here. Where? The worksheet deals with these 2 rules. Well, actually these 3, but we've been talking about this one. These 3 properties of logs, which are pretty nice, actually. One of them says, first of all, we already talked about the exponent, and that's probably, not that any one property is better than the other, but that's very useful, being able to knock the exponents out of an equation. Later on, when we get into some serious equations, you'll see, without that, we'd be in big trouble. But since we can knock the exponents down to a workable level, In other words, we can get n plus 10 down to somewhere we can work with it. Makes all the difference in solving or not solving. But these other two are very useful as well. This is when you multiply two things in a log, you can actually do the same thing by taking the individual logs and adding them. And when you divide, you subtract. This works out nice too. And combined with this third one here, we can work with this worksheet a little bit. So let's do a couple problems from there. Start with the very basic number 1, log of 6 times 11. According to this, take a note here that on the first page, all the logs have no base written underneath them. So that's assumed to be what? Base 10, okay? Because it doesn't matter what the base is, so they're just using the easy one, base 10. But it all works. Of course, the bases have to be the same. Okay, this does not say log base A and log base B. They're both the same A's because it all have to be the same basis for any of this to work. So this becomes simply log base 10 of 6, or I'll just say log 6 plus log 11. I like to put them in parentheses for this stylistic whether you do or not. You could double check this. We could actually do the multiplication in here and say 6 times 11. This is just a check. You don't need to do this, but I like to show you. What is 6 times 11? 66, right? That log is this. If I take log of 6 and I then add it to log of 11, what should my answer be according to these rules? Same thing. So it's nice to see that the calculator knows the property, right? I'm a humorist and not going to make it in math. I don't know what to do. Okay, the property says that when you multiply them inside the parentheses, you add them outside. That's the property. And the same thing goes when you subtract. When you divide them, you subtract. That's what we're working with. Why that works? I can show you, but you'll never have to show it back to me, and you just know how to use it. So if you're interested in why it works, come see me in my office, and I'll run through the proof with you. In the meantime, you guys who just want to get through this, please commit this to memory, okay? It's very common. It's nice that it works, and I can show you using other properties of logs that it is indeed true. So if you want to, stop by my office, we can play with that. Let's do another one. Number 5. Okay, this one I'm going to first recognize as division here, and then when you divide, what do you do outside? Subtract, so this is log 2 to the 4th minus log 5, and then I can furthermore take this one and write this as 4 log 2 minus log 5, because I can move the exponent out front. That's the top property. So it's pretty straightforward.
On number 3, would you apply the 5 to both logs since it's outside of the parentheses?
I would, and I would write it like this. Number 3, log 6, 11 of raised to the 5th. I would go ahead and move it out first. That's 6, 11. So there's 6 and 11. Okay, and then I would recognize this is equal to 5 times log 6 minus log 11 because, again, subtraction and division. And then you can use the distributive property here and get 5 log 6 minus 5 log 11. And no, that's not the only way to do it. An alternative method would be to apply the 5 to both pieces, so that here you could then just write the log with 5 out front. Doesn't matter. 6 and 1/2 dozen of the other, if you will. All right, and on the second page, we have the other way. Now, these can be a little bit more complicated, not too much. Basically what they're saying is, can you go from here back to here? We just went one way, we expanded. Now the other word is to condense or simplify is oftentimes used too. So let's see.